Hello.
Hello.
Yeah, one second, one second.
Hello. Yeah, I think we should start. Um, yeah, the question is, given the data set, choose the optimal lesson tree learned by a greedy approach. So we are here uh, putting on a greedy approach and try to find the optimal lesson tree learned for this data set. So there's three options. The fourth one is none of the above. You can try it once and give an answer, and I'll solve it once you're done. Yeah, so as you can see, is there any answers? No. Yes. Yeah. So as you can see, if so, this is the data set, and data set is like this. There are three variables A, B, and C, and we have the Y, or the prediction that we have. So A has value false, true, true, true. B has value false, false, true, true. C has false, true, false, true. And the Y is our F, false, true, true, false, right? So if I make the decision on A, if I based my decision on A, right? So if A is false, then my Y is false. If A is false, my Y is false. But if A is true, if A is equal to true, if A is false, Y is false. So I'm just trying to make a rule out of it. If A is true, then the value of Y is not fixed. Okay. So then we'll go for like the second variable B. So if A is true, then we'll go one level deeper. If B equal to false, if B equals to false, A is true and B is false, the value is true. Y equals to true. If B equals to true, then value of Y can be true or false. So in this case, we'll go one level deeper and see the value of C. Okay. If C equals to false, Y equals to true. If C equals to true, Y equals to false. Okay. So this is sort of a rule that you can follow to construct the tree. Okay. But this is one of the way we can construct the tree. But is it correct way of constructing tree? The answer is no. It is no because the question is saying that we have choose the optimal decision tree learned by greedy approach. So we're doing a greedy approach, and in the greedy approach, we have to find the minimum way we can split so that we'll get a better tree, right? Like the minimum depth, so that it will be easier to parse and everything else, right? So if you see the data set here on top, you can see the Y can be described as a function of B and C. That means if B and C are false, it is false. If B and C is true, false, or false, true, it is true. And if both are true, it is false. So this reminds of one function, that is XOR function. So Y is just B, and this is a function of B and C, and A is don't care. Okay. Irrespective of the value of A, we can make a decision just by looking at B and C. Okay. So we can start splitting at B. So if we look at B, so if B equals to false, then we can look for this C. So if B equal to false and if C equals to true, that will give Y equals to false, true is true, and if C equals to false, Y would be false. False, false is false. False, false is false. False, true is true. Then again, if B equals to true, again two part. If C equals to true, true is false, and if C equals to false, Y equals to true. True, false is true. All these things are taken from here. False, false is false. False, true is true. False, true, false is true. True is false. So if we just consider B and C alone, we don't need to look at A, and we still can make decision on Y. So if you have to create a greedy tree, then this would give us 2-layer trees, which is true here. Hence, option C would be the correct answer for this question. Yeah, so option C would be correct answer for this question. Any doubt on the same? You can ask now.
So why didn't we consider A?
Yeah, so we, as I said, like if we consider A, we still can make a valid tree like this. This could be the answer, but since we are like looking for greedy approach, we have to minimize the number of, like, the depth that we are considering.
So we are going for trees with less levels.
Sorry,
We are
could you repeat?
going for trees with less levels.
Yes. We're going for trees with the least number of levels, since it is a greedy algorithm. So we're going for the trees with so there are like different conditions we can split out trees. So if you choose greedy, so this is one of creating the trees. So decision trees are like, is like machine learning, but it's mostly like a rule based algorithm where we are putting rules based on the data that you have seen. So we're creating the rules on the fly. So based on the feature that we have, feature range and the y value that we have, we're creating the rules on the fly and applying the rules on the data set that we have. Okay. So if the combination of true false were different, our decision tree would have been different as well. A slight change in the features cause a very um, significant change in the decision tree construction as well as our target value y. So given this said, let's go to the next question. Next question is question number 2. Which of the following properties are characteristics of decision trees? Is high bias, high variance, lack of smoothness of prediction surfaces on one parameter set. I can help you in the one, like out of A and B, one could be the solution because a model cannot be high bias as well as high variance, or low bias or low variance. It can be high bias, low variance, or high variance, low bias. So sorry, I didn't check the B and D. We're voting for okay. B and D, B. So it's a multiple choice question. So the solution to this is like three options. Okay. As I just discussed earlier, so dysenteries are very unstable, considering that if you change a small amount of data, if you change a small amount of data, that can result in a very different set of splits. So if I just change from one true to false or any value, it will like result in a very different set of um, dysenteries, and that makes it very highly variant, with a high variance to the data for the data set. So this is mainly due to the hierarchical nature of the dysenteries. So if you change a split initially, so all the other splits that is coming after that in the tree, in the subtrees, will also be affected. So this is how, like, if one thing changes, a lot of things changes. That's how, like, it is high variance. So that will imply that it is not high in bias. Second is lack of smoothness in the prediction surface. So if you look at the dysenteries in general, so let's say there are two variables. Okay, so the way the dysentery makes decision is that there is x1, x2, and y, and this, let's say, x1, x2, and y. So the thing is that you have let's say some values here, x1 values, and they have some values in x2 as well. So the value of y would be like some 0 or 1. Let's say it's like that. Okay. So what it will do is that it will look at all the zeros and it will look at all the ones. Then it will make a decision, right? It will make a decision that, okay, if the value of x1 is more than, let's say, there's some value theta 1, and if the value of x2 is more than, let's say, theta 2 or something like that, then this is a 0 or it is 1, something like that, right? So if I plot this, it would be like, okay, if the value of x1, so if I make a dysentery, it will be like, x1 theta 1 less than theta 1, x2 greater than okay. So this is x1 equals theta. All this point is x1 less than theta 1, and all this point are like x1 greater than theta 1. And okay, so for this axis, this is your x1, and for this axis x2, so we have to find another line like that. Okay, if it is less than theta 2, then it is some y equals to 0 or something. If it is more than that, there is something. So it sort of creates a piecewise distance boundary or distance surface. So if you know piecewise functions are like this, right? So they have like the value of y is piecewise dependent on x. So a smooth function is like this. It's smooth, and the piecewise. since the distant boundary of this distant tree is like piecewise, we can say that lack of smoothness in the prediction surface. If you look at the prediction surface of neural network, they'll be smooth like this, but it's not smooth for distant trees. Okay. And the third is the unbounded parameter set. This is also true because so distant boundary does just look at the data and try to like learn a function. It is not assuming anything about the parameter. It is not assuming about anything about the data, the distribution of the data. So that's why, like, these are non-parametric methods where the number of parameters depend solely on the data set on which training is carried out. Okay, so it is not dependent on any sort of parameter that is like concerned with the data distribution. That's why we can say that it is an unbounded parameter set. It is not bounded by the distribution of the data. If you see logistic regression or naive Bayes algorithm, they assume something about the data. They assume that the logistic, in case of logistic regression, y x given y is distributed normally. Okay, so this is the assumption of naive Bayes. But in case, sorry, not naive Bayes, logistic regression. But in this case, there is no assumption. That's why it can be said that it has unbounded parameter set. So option D is also correct. Okay. So let's go to the question number 3. I think question number 3 is just a direct question, and you can answer it correctly. Just a direct question, like you just have to put the formula and get the answers. Yeah, try question number 3. Three is 1. Is in the answer 1 or option 1?
Answer 1, third option, C.
Okay. So we'll solve it. So entropy is so you just have to apply the formula of entropy. It's a 50-50 split into two classes. So hence the probability of class 1 is 0.5 and probability of class 2 is 0.5, and entropy is equals to sigma 1 to n pi times log pi, log base 2 pi, right? So if you apply the formula, let's just take the minus as common. Pi is 0.5, then log 2 0.5, right? Then plus, since we have taken the minus as common in the outside, so you can write 0.5 log base 2 0.5, right? So if we calculate that, minus log base 2 0.5 is 1/2, right? Log 1 by log 1 is -1, log 2 base 2 is 1. So that will be -1. So this will result in -1. Okay, so that will be minus 0.5 times log 0.5 base 2 is -1. Okay, plus 0.5 times -1. So this minus 0.5 minus 0.5 plus minus 0.5, it will be minus 1. So option C is correct. Yeah, I think I need to move this one for a bit. Having built a descent tree, question number 4, and look at question number 4. Having built a descent tree, we are using reduced error pruning. So I hope you are familiar with reduced error pruning. We're using reduced error pruning to reduce the size of the descent tree. We select a node to collapse for this particular node on the left branch, there are three training data points with the following feature values 5, 7, and 9.6. And for the right branch, there are 4 training data points with the following feature values. This. What were the original response for the data points? So, question is, what were the original response for the data points along with the 2 branches, left and right respectively? And what is the new response after the collapsing the node? There is the information. These are the question. Yeah, so if I start solving it, so this is my, let's say, node of interest. Okay, so on the left, there are 3 data points. That is 5, 7, and 9.6. On the right, there are 4 data points. 8.7, 9.8, 10.5, and 11. Okay. So what were the original response for the data points? So it's sort of a prediction task. It is asking what were the original response for the data points. So if you know the formula for that, you can easily get it. And if you know the algorithm for collapsing a node, how to merge all these data points to get a response, then the second question would have been also. So it's like left, right, and collapse. Yeah. So if you find the value in the left, it's just the mean. If you know the formula already. So so the left side responses is 5, 7, 9.6. Just add them by 3. It will be 12, 9, 21.6 by 3 will be 7.2. Okay. You go right will be 10. You know how? Because only one option is 7.2, 7.2, and it's 10, 10. So right will be 10. But I can calculate that, I guess. So take the mean 8.7 plus 9.8 plus 10.5 plus 11 by 4. That will be 10, 11 is 21. 21, 9 is 30. 30 plus 8 is 38. 38. And 8 plus 7 is 15. 5, 20. So 38 plus 2 is 40 by 4 will be 10. And if we collapse this and we make just and prune the node by collapsing it, the new response for this would be, it will be 7.2 into 3 plus 10 into 4, okay, and divided by 3 plus 4. That would be 7.2 into 3 by 7 plus 10 into 4 by 7. Okay, so that this was easier. So this will be 7.2 into 3 is 21.6 plus 40 by 7, 61.6 by 7. No, 8.4, 5, 5.6, 56, 56, 8, 8.8. So this would be done. Then 1 to 10 and 8.8. Hope there is no doubt on this. Just look at the solution once. Fine. We'll take 2 minutes break. Just start after 2 minutes. So sorry, I should have showed you the next question, question number 5. Question number 5 is pretty straightforward. Yeah. So just check out the question first and discuss the solution. Given that we can select the same feature multiple times during the recursive partitioning of the input space, is it always, so just notice this question, is it always possible to achieve 100% accuracy on the training data, given that we allow the tree to grow to their maximum size? So we are allowing the tree to grow to the maximum size. Given that, is it possible, and also we can split on the same variable again and again. Given that, is it always possible to achieve 100% accuracy on the training data? It's not actually forcing you to achieve the accuracy on the testing data, on the training data, right? So is it possible? So when it is asked, is it possible or not, you have, if it is not, if it is yes, you can prove that, but if it is not, you have to find at least one case where it is not possible. So try to think about it for 2 minutes. I'll just give you the solution. Question number 7 and 8 are a bit longer, so I'll try to go through 5 and 6 quickly so that I can discuss 6 and 7 in an extended way. Just calculation, but it's a bit longer. Okay, so the answer is no. I'll tell how. So let's say there is a variable x and there is y. Let's say the value of y x is like, let's say 2.5 and 2.5. A value of y for this 2.5 is 0, 1. So even if we split on x multiple times to an infinite depth, we will never achieve this solution, because on the same value, one level is 0, one level is 1. So for this data set, we cannot achieve the 100% accuracy. And since we have one contradicting case, we can say that this entire thing will not be true. Okay, the entire thing will not be true, since it will be false. Next question, suppose on performing reduced error pruning, so the one that we saw here, the reduced error pruning, we collapsed a node and observed that an improvement in the prediction accuracy on the validation set. Which among the following statements are possible in the light of the performance improvement observed? So what you did is that you sort of selected a node, you collapsed it, and you see, and in that way, like, you reduce the depth of the tree, and also the size of the tree, and you see that there is a improvement in the performance of the cell. The question it is asking here is that what could be the reason for the performance improvement in the distant tree? Okay. So it's saying that let's say that we collapsed a node. There is a node and we collapsed it and make it the tree smaller. When we like build a descent tree and we collapsed one of the trees on the node, the general criteria is that it should increase the noise, increase the error in the decision making, but an improvement is seen. So which of the following options could be one of the reason for this improvement? Option A is the collapsed node helped overcome the effect of one or more noise affected data points in the training data. So first option is kind of error. So this kind of error actually we normally expect the pruning to help us overcome. So hence this option A would be incorrect. Sorry, option A would be correct, because so we want the pruning, so we expect the pruning would help us overcome this type of error. Which type of error? The effect of one or more noise affected data points in the training set. So if one or more, so let's say in the data set we have some noise. So you say like, why do we have noise in the data set? The thing is that the data set that we collect in the real world doesn't often come with all cleaned and all valid data points. There might be some outlier. There might be some error while capturing the data. There might be some error while collecting the data or like storing the data. So this type of error is usually removed in during the pruning thing. So the option A that says that so maybe the point that we removed was a noisy data, and since we removed that now, the accuracy has improved. So the collapse node helped overcome the effect of one or more noise affected data point is true, because there might be some error. Right?
Why you do that?
Yeah. And the second option is, just evaluate the second option. The second option is validation set had one or more noise affected data points in the region corresponding to the collapse node. So I didn't. Yeah. So I think the prediction and accuracy the validation set. So you see, so it's saying that after the pruning is done, it has increased the accuracy on the validation set. So there might be one reason that the validation set had one or more noise affected data points in the region corresponding to the collapse node. So if the validation set has also noise, and if we do the pruning, that noise can also be identified by this pruning and removed. So that might have also helped in increasing the accuracy or the increase in the or the improved the performance of the model. That might be another case that we can think of. A is correct and B is correct. Then option C. Option C is the validation set did not have any data point at least one of the collapsed branches. So so if like if there is, so the validation set might have the error in its data set in that region, or the validation set might not contain the data set any data in that region. So in that case, by removing that, it might also improve the performance, or it might not decrease the performance at least in that case. Okay, so that also makes the option C as correct. Option D is that the validation set did not contain data points which were adversely affected by the collapse node. So this will be incorrect, as as like even if the increased error due to the collapsed node is registered in the validation set, so it may be the case that the masked it may be like masked by the absence of errors in other parts of the validation set, which was present in the training set. So due to this reason, like option D would be likely incorrect. Okay, and option A, B, C would be correct. So if you just think simply, it is like it is saying that we in the dysentery there are some nodes here and there. We collapsed a node. Okay, that means we're chopping out down the dysentery, this dysentery, and we're chopping a portion of it and making it shorter. This should result in decrease in error, but somehow we saw that it has increased the validation accuracy, validation performance. Why it is that? One, the first option is that maybe the data point that we made the tree, that maybe the data point that made the tree has some error values in this region. Hence, by removing this, it is increasing. Or the training set might have some points, or second is validation set might have some points. That is two options. So option A and B. Option C is that let's say the validation set doesn't have any point in this region, so we're not making any decision in this region. Hence, by removing this, is not actually affecting the performance, or at least not decreasing the performance. Hence, option C is true, and option D is false because it is the opposite thing that option C is telling us. Right. I'll move on to the next question. Question number 7. If you have any doubt on the question number 7 and 8 are on this as the same question, but it is saying that consider the following data set and consider the profitability, that is the final column, as the binary values. It's a binary classification problem. Binary values attribute we're trying to predict. So these are y. Okay. Which of the attribute would you select as the root in a dysentery with multi-way split using the cross entropy impurity measure? And the second question is for the same data set. So for the same data set, suppose we decide to consider dysentery using binary split and a Gini index impurity measure. Which among the following feature and split point combination would be the best to use as a root node, assuming that we consider each of the input feature to be unordered? So it is the same data point, and we are just trying to find the root node and the first split point. Okay, for these two type of impurity measure, cross entropy impurity measure and the Gini index impurity measure. So try to solve this. I'll make some gap between these two to solve it. Yes, should we sorry, should we select minimum cross entropy with respect to target? One asked. Yes, you have to select the minimum cross entropy with respect to target. And also, like when we are doing the Gini impurity as well, we also need to select the minimum impurity, minimum Gini impurity. Okay, I'll make some room here for you to solve. Guys, I start solving with this a bit bigger to solve. So it's just formula, so you don't have to do much thing. So if we do cross entropy of price, okay, that would be, so if you look at the price, did someone answer the question already? No. Yeah, perfect. So if you look at that, so if you look at the price here, so if you see there are 1, 2, 3, 4 lows, 1, 2, 3, 4 medium, and 1, 2, 3, 3 highs. The total is 11. So it will be like 4 by, first we'll consider the low, price as low. So there are 4 by 11. And out of this 4 low, we have 2 yes. So if you see here, we have 2 yes and 2 no, right? For yes, it will be minus 2 by 4, the same cross interval formula, log 2 by 4 base 2. Then for yes, 2 by 4 log 2 by 4 base 2. Okay. Plus for medium, similarly, we have 2 yes, 2 no's. So it will be 4 by 11. So it will be the same thing, exact same thing, 2 yes, 2 no. So I'll just multiply 2 here into 2 plus for high is 3 by 11, and for high there is 2 yes, 1 no. So if you do for no first, minus 1 by 3 log 1 by 3 minus 2 by 3 log base 2 by 3. Okay, this for the price, right? So if you solve this, it will be, this is 1 by 2, so this is 1. No, this is 0.5, right? This is 0.5 as well. This is 0.5, 0.5, so it is 4 by 11 minus 0.5 times 0.5 minus 0.5 times 0.5 into 2, okay, plus 3 by 11 minus 1 by 3 log 1 by 3 base 2. Can someone calculate? So log 1 by 3 base 2. Minus 1.58 minus 1.58 minus 2 by 3 log 2 by 3 is minus 5.8. So it's minus 0.58. It will be 4 by 11 is minus 1 by 4 minus 1 by 4, and if you add this, it will total up to minus 1 by 2, and like minus 1 by 2 into 2 cancel plus 3 by 11 into minus plus, so plus 1.58 by 3, then minus plus 2 by 3 into, sorry, 1.58 is added here, right? No, it's multiplied. So this is plus 2 by 3 into 0.58 into 0.58 into 3 by 11. It is minus 4 by 11 plus this multiplication, 3 cancel, 1.58 by 11 plus 3 cancel into 2 is 1.16 by 11. That is equal to, let me use a calculator. It will be equal to 0.9777, approximately like this. Okay. So I'll not be solving the entire thing. So I'll be using the calculator now. I'll just write the formulas and I will use the calculator and give you the values. You do the same as well. So for the maintenance, gross entropy of maintenance would be, if you apply the formula, similarly, I have another screen open, so you can take, like, match it with another screen. So it will be like there are 2 lows and 4 medium and 5 high. So it will be 2 by 11 minus 2 by 2 log base 2 by 2 minus 0 by 2 log base 2 0 by 2. The reason 0 by 2 is because, like, if you see the low, it is always yes. Okay, so there is no. Plus 4 by 11 minus 2 by 4 log base 2 by 4 minus 2 by 4 log base 2 by 4 plus 5 by 11 minus 2 by 5 log base 2 5 minus 3 by 5 log base 2 3 by 5. Into this calculation, I'm writing for others as well. Capacity equals to 3 by 11 minus 1 by log 2 1 by 3 minus 2 by 3 log 2 by 3 plus 6 by 11 minus 3 by 6 log 2 3 by 6. It's very easy. If it is 3, the next one will be 3 as well, because this both should add up to 6. 3 by 6 into log 2 3 by 6, and total is 11. 3 6 and 3 is gone, only 2 is left, so plus 2 by 11 minus 2 by 2 log 2 by 2 minus 0 by 2 log 2 0 by 2. Calculate this as well, and I'll let the final cross entropy of air bag Airbag is 5 by 11 minus 3 by 5 log 2 3 by 5 minus 2 by 5 log 2 2 by 5 6 by 11. So if I calculate all these things, give me 2 minutes, I'll calculate all these things. The calculator, you can meanwhile you can calculate as well. And we have to select the minimum of this 4. First one is this 0.9777. Want to calculate the rest 3. Give me 2 minutes. Yeah, so after calculating, I think you can say that this is the lowest value. Hence, the capacity should be the root node in this case. We'll apply the formula and get the solution. For the final question, did anyone didn't calculate that on their own? No, we'll do the final one. So the first one is like, so it's same thing, we just need to apply the Gini impurity formula. If you go to the lecture, you'll find this formula, how to apply it. It is Gini on price, low, medium, given high. Okay. So the formula would be like this. Let me show the. Yeah. So. So low, medium is on one side and high is on the other side. So low and medium are 8 for price and high is 3. So that's how we divide it first. Then out of this 8, 1, 2, 3, and 4. 4 are yes and 4 are no, right? And out of these 3, 2 are yes and 1 is no, right? So the way we'll do this is that if it is getting split on low and medium in one side and high on other side, the number of low and medium is 8, total is 11, plus then high is 3 by 11. Okay, we multiply it by 2, then we'll multiply this by the number of yes and no. So number of yes, as I think, is 4 and no is 4 also for the low and medium. So it is 4 by 8 times 4 by 8 plus here the number of yes is 2 and number of no is 1 into 1 by 3. So this will give me is 2 to cancel 4 by 11 plus 3 cancel 4 by 11 into 3. That will be 11 into 3, 12 plus 4, 16 by 33. What is 16 by 33? 16 by 0.4848 is equal to 0.4848. Okay. Similarly, if we do the Gini for this, Gini for maintenance, where one side is high, the other is medium and low. Okay. For the maintenance, one side is high, right? So let's just erase this. Maintenance is one side is high and second is medium and low. So low, medium, low, high, medium, high, medium, high. So one side is high. So high would 1, 2, 3, 4, 5. It would be 5 by 11 plus the rest would be 6 by 11. Medium and low. Okay. Into 2 into 2 into. Then we'll see what's the value for high. So for high, 1, 2, 3, 4, 5. For high, it is no, sorry. For high, it is 1 no, 2 no, 1 yes, 3 no, 2 yes. So yes, 3 by 5 to 2 by 5. Okay. Similarly for this, 1 yes, 1 no, 2 yes, 3 no, 3 yes, 4 yes. So 4 by 6 into 2 by 6. We'll calculate this. Cut 12 by 55 plus 3, 8 by 33. This will be, let me calculate that. 12 by 55, 0.21 plus 8 by 33. 8 by 33. 0.24 equals to 0.45. Okay. Similarly, if we do Gini of maintenance, what we did high, sorry, and medium, and put low on the other side, the values that we will get will change. So you can
Sir, why are you multiplying with 2 in every case here?
Open 4 and left with 440 0 40. So this will be the value of third, and the fourth is capacity 2 or 4.5. So Gini of capacity 2 or 4.5 would be 3 by 11 times 2 times 1 by 3 times 2 by 3 plus 8 by 11 into 2 into 5 by 8 into 3 by 8 4 by 33 plus it cancel 4 by 44. If you solve this, it will come out to be 0.4621. Okay, and since this is the lowest one, so this would be the answer, which is maintenance high, medium, or low. Option C. Okay, so this is the way you can calculate
It's very simple. Just need to do the thing. Okay. Yeah. So this ends our conversation and interaction for today. If you have any doubt, you can ask. And the recording version of this tutorial will be uploaded to the YouTube, and you can find the link in the shared document that is shared with you in the NPTEL website, I guess. I can share the channel. In the chat. So you can follow this channel for the video. Until then, bye-bye. Thank you for joining, and we're ending this session now. Thank you.